XORG, the X11 server. In this video, we are going to see about XORG, the X11 server. While the heart of Red Hat Enterprise Linux is the kernel, for many users, the face of the operating system is the graphical environment provided by the X Windows system, also called X. Other windowing environments have existed in the Unix world, including some that predate the release of the X Windows system in June 1984. Nonetheless, X has been the default graphical environment for most Unix-like operating systems, including Red Hat Enterprise Linux for many years. The graphical environment for Red Hat Enterprise Linux is supplied by the XORG Foundation, an open-source organization created to manage development and strategy for the X Windows system and related technologies. XORG is a large-scale, rapidly developing project with hundreds of developers around the world. It features a wide degree of support for a variety of hardware devices and architectures, and can run on a variety of different operating systems and platforms. This release for Red Hat Enterprise Linux specifically includes the X11 R7.1 release of the X Windows system. The X Windows system uses a client-server architecture. The X server, that is the XORG binary, listens for connections from X client applications via a network or local loopback interface. The server communicates with the hardware, such as the video card, monitor, keyboard, and mouse. X client applications exist in the user space, creating a graphical user interface, that is GUI, for the user and passing user requests to the X server. XORG server design. In this video, we are going to see about XORG server design. Red Hat Enterprise Linux 5.10 now uses the X11 R7.1 release as the base X Windows system, which includes several video driver, exe, and platform support enhancements over the previous release, among others. In addition, this release also includes several automatic configuration features for the X server. X11 R7.1 is the first release to take specific advantage of the modularization of the X Windows system. This modularization, which splits X into logically distinct modules, makes it easier for open-source developers to contribute code to the system. In the X11 R7.1 release, all libraries, headers, and binaries now live under /user/ instead of /user/X11R6. The /etc/X11/ directory contains configuration files for X client and server applications. This includes configuration files for the X server itself, the XFS font server, the X display managers, and many other base components. The configuration file for the newer Fontconfig based font architecture is still /etc/fonts/fonts.conf. The X server performs advanced tasks on a wide array of hardware. It requires detailed information about the hardware it works on. The X server automatically detects some of this information. Other details must be configured. The installation program installs and configures X automatically unless the X11 R7.1 release packages are not selected for installation. There are any changes to the monitor, video card or other devices managed by the X server, X must be reconfigured. The best way to do this is to use the X configuration tool, that is System Config Display, particularly for devices that are not detected manually. In Red Hat Enterprise Linux default graphical environment, the X configuration tool is available at System, that is on the panel Administration Display. Changes made with the X configuration tool take effect after logging out and logging back in. In some situations, reconfiguring the X server may require manually editing its configuration file /etc/x11/xorg.conf. XORG server configuration. In this video, we are going to see about XORG server configuration. The X server is a single binary executable, that is /user/bin/xorg. Associated configuration files are stored in the /etc/x11/ directory, that is a symbolic link X which points to /user/bin/xorg. The configuration file for the X server is /etc/x11/xorg.conf. The directory /user/lib/xorg/modules/ contains X server modules that can be loaded dynamically at runtime. By default, only some modules in /user/lib/xorg/modules/ are automatically loaded by the X server. To load optional modules, they must be specified in the X server configuration file /etc/x11/xorg.conf. When Red Hat Enterprise Linux 5.10 is installed, the configuration files for X are created using information gathered about the system hardware during the installation process. XORG.conf. While there is rarely a need to manually edit the /etc/x11/xorg.conf file, it is useful to understand the various sections and optional parameters available, especially when troubleshooting. The structure: the /etc/x11/xorg.conf file is comprised of many different sections which address specific aspects of the system hardware. Each section begins with a section, that is section name line, where section name is the title for the section, and ends with an end section line. Each section contains lines that include option names and one or more option values. These are sometimes enclosed in double quotes. Lines beginning with a hash mark are not read by the X server and are used for human-readable comments. Some options with the /etc/x11/ .xorg.conf file accept a Boolean switch which turns the feature on or off. Acceptable Boolean values are 1 on true or yes turns the option on, 0 off false or no turns the option off. The following are some of the more important sections in the order in which they appear in a typical /etc/x11/xorg.conf file. More detailed information about the X server configuration file can be found in the xorg.conf man page. Server flags. The optional server flags section contains miscellaneous global X server settings. Any settings in this section may be overridden by options placed in the server layout section. Each entry within the server flags section is on its own line and begins with a term option followed by an option enclosed in double quotation marks. Server layout. The server layout section binds together the input and output devices controlled by the X server. At a minimum, this section must specify one output device and one input device. By default, a monitor that is output device and keyboard that is input device are specified. The following entries are commonly used in the server layout section. Identifier specifies a unique name for this server layout section. Screen specifies the name of a screen section to be used with the X server. More than one screen option may be present. XORG modularity. In this video, we are going to see about XORG modularity. Red Hat Enterprise Linux uses two subsystems to manage and display fonts under X Fontconfig and XFS. The newer Fontconfig font subsystem simplifies font management and provides advanced display features such as anti-aliasing. This system is used automatically for applications programmed using the Qt3 or GTK+2 graphical toolkit. For compatibility, Red Hat Enterprise Linux includes the original font subsystem called the Core X Font subsystem. This system, which is over 15 years old, is based around the X font server, that is XFS. Fontconfig. The Fontconfig font subsystem allows applications to directly access fonts on the system and to use XFT or other rendering mechanisms to render font config fonts with advanced anti-aliasing. Graphical applications can use the XFT library with Fontconfig to draw text to the screen. Over time, the Fontconfig/XFT font subsystem replaces the core X font subsystem. It is important to note that Fontconfig uses the /etc/fonts/fonts.conf configuration file, which should not be edited by hand. Adding fonts to Fontconfig. Adding new fonts to the Fontconfig subsystem is a straightforward process. To add fonts system-wide, copy the new fonts into the /user/share/fonts directory. It is a good idea to create a new subdirectory such as local or similar to help distinguish between user-installed and default fonts. To add fonts for an individual user, copy the new fonts into the .fonts/ directory in the user's home directory. Use the fc-catch command to update the font information cache as in the following example. In this command, replace path to font directory with a directory containing the new fonts, that is either /user/share/fonts/local or home/user/.fonts/. Server and client relationship. In this video, we are going to see about server and client relationship. The X Windows system is activated as a combination of the server and client programs. The meaning for the words server and client with respect to the words local and remote requires attention here. Modern X servers have the MIT shared memory extension and communicate with their local X clients using the local shared memory. This bypasses the network transparent XLIB interprocess communication channel and gains performance for large images. XORG in Runlevel 3. In this video, we are going to see about XORG in Runlevel 3. In most cases, the Red Hat Enterprise Linux installer configures a machine to boot into a graphical login environment known as Runlevel 5. It is possible, however, to boot into a text-only multi-user mode called Runlevel 3. Runlevel 3. When in Runlevel 3, the best way to start an X section is to log in and type startx. The startx command is a front end to the xinit command, which launches the X server, that is XORG, and connects X client applications to it. Because the user is already logged into the system at Runlevel 3, startx does not launch a display manager or authenticate users. When the startx command is executed, it searches for the .xinitrc file in the user's home directory to define the desktop environment and possibly other X client applications to run. If no .xinitrc file is present, it uses the system default /etc/x11/xinit/xinitrc file instead. The default xinitrc script then searches for user-defined files and default system files, including .xresources, .xmodmap, and .xkbmap in the user's home directory, and xresources, xmodmap, and xkbmap in the /etc/x11/ directory. The xmodmap and xkbmap files, if they exist, are used by the xmodmap utility to configure the keyboard. The X resources file is read to assign specific preference values to applications. After setting these options, the xinit rc script executes all scripts located in the /etc/xlaven/xinitrc.d/directory. One important script in this directory is xinput.sh, which configures settings such as the default language. Next, the xinit rc script attempts to execute .xclients in the user's home directory and turns to /etc/x11/xinit/xclients if it cannot be found. The purpose of the xclients file is to start the desktop environment or possibly just a basic window manager. The .xclients script in the user's home directory starts the user-specified desktop environment in the .xclients default file. If .xclients does not exist in the user's home directory, the standard /etc/x11/xinit/xclients script attempts to start another desktop environment, trying gnome first and then kde followed by twm. When in Runlevel 3, the user is returned to a text mode user session after ending an X section. XORG in Runlevel 5. In this video, we are going to see about XORG in Runlevel 5. When the system boots into Runlevel 5, a special X-client application called a display manager is launched. A user must authenticate using the display manager before any desktop environment or window managers are launched. Depending on the desktop environments installed on the system, 3 different display managers are available to handle user authentication. GNOME, the default display manager for Red Hat Enterprise Linux. GNOME allows the user to configure language settings, shut down, restart or log in to the system. KDE, KDE's display manager, which allows the user to shut down, restart or log into the system. XDM, a very basic display manager which only lets the user log into the system. When booting into Runlevel 5, the prefdm script determines the preferred display manager by referencing the /etc/sysconfig/desktop file. A list of options for this file is available in this file, where version number is the version number of the init scripts package. Each of the display managers reference the /etc/x11/xdm/xsetup/0 file to set up the login screen. Once the user logs into the system, the /etc/x11/xdm/give console script runs to assign ownership of the console to the user. Then the /etc/x11/xdm/xsession script runs to accomplish many of the tasks normally performed by the xinit rc script when starting X from the Runlevel tree, including setting system and user resources as well as running the scripts in the /etc/xlavin/xinit/xinit-rc.d/directory. Users can specify which desktop environment they want to utilize when they authenticate using the GNOME or KDE display managers by selecting it from the Sessions menu item, that is, accessed by selecting System on the panel. Preferences. More preferences. Sessions. If the desktop environment is not specified in the display manager, the /etc/x11/xdm/x session script checks the .x session and .x clients files in the user's home directory to decide which desktop environment to load. As a last resort, the /etc/x11/xinit/xclients file is used to select a desktop environment or window manager to use in the same way as Runlevel 3. When the user finishes an X session on the default display, that is 0, and logs out, the /etc/x11/xdm/take console script runs and reassigns the ownership of the console to the root user. The original display manager, which continues running after the user logged in, takes control by spawning a new display manager. This restarts the X server, displays a new login window, and starts the entire process over again. The user is returned to the display manager after logging out of X from Runlevel 5. For more information on how display managers control user authentication, refer to the /user/share/doc/gdm version number/readme, where version number is the version number for the GDM package installed, and the XDM man page. Configuration utilities. In this video, we are going to see about configuration utilities. Configuration utilities. XORG supports most common video cards, keyboards, and pointing devices. These devices are automatically detected and do not require any manual configuration. If XORG has been used on this computer before, move or remove any existing configuration files. Add the user who will run XORG to the video or wheel group to enable 3D acceleration when available, to add user JRU to whichever group is available. The TWM window manager is included by default. It is started when XORG starts. On some older versions of FreeBSD, the system console must be set to VT4 before switching back to the text console will work properly. Video cards. Intel R. 3D acceleration is supported on most Intel R graphics up to LVY bridge, that is HD graphics 2500, 4000 and P4000, including Iron Lake, that is HD Graphics and Sandy Bridge, that is HD Graphics 2000. Driver name Intel, AMD or Radeon. 2D and 3D acceleration is supported on Radeon cards up to and including the HD 6000 series. Driver name Radeon. NVIDIA. Several NVIDIA drivers are available in the X11 category of the ports collection. Install the driver that matches the video card. Setting the video driver in a file. To set the Intel R driver in a configuration file, select Intel R video driver in a file. If more than one video card is present, the bus ID identifier can be uncommented and set to select the desired card. A list of video card bus IDs can be displayed with PCIconf LV GREP B3 display. Keyboards. Keyboard layout. The standardized location of keys on a keyboard is called a layout. Layouts and other adjustable parameters are listed in X keyboard config, that is 7. To select an alternate layout, set the XKB layout and XKB variant options in an input class. This will be applied to all input devices that match the class. This example selects a French keyboard layout with the OSS variant. Setting a keyboard layout. Setting multiple keyboard layouts. Cycle through these layouts by pressing Alt plus Shift. X11/XXKB or X11/SBXKB can be used for improved layout switching control and current layout indicators. Closing XORG from the keyboard. X can be closed with a combination of keys. By default, that key combination is not set because it conflicts with keyboard commands for some applications. Enabling this option requires changes to the keyboard input device section. Enabling keyboard exit from X. Remote X sessions. In this video, we are going to see about remote X sessions. In order to obtain the ability to interact with an X11 GUI remotely, we will follow these general steps. Ensure that the foundational X11 packages are installed. Ensure that OpenSSH server is configured to forward X11 connections. Configure a local X11 server on our workstation. Configure our SSH application to forward X11 requests. Test with a simple application. Configured authentication if user changes are needed. Move on with the task at hand. Ensure that the foundational X11 packages are installed. In order to use Remote X11, you must have a few X11 packages installed on the server. rhel/centos/fedora, that is Xterm is optional but beneficial for testing. Ensure that Open SSH server is configured to forward X11 connections. On RHEL and related Red Hat based servers, the file to check is /etc/ssh/sshd_config. If that line is preceded by a command hash or is set to number, update the file to match the above and restart your SSH server DAEMON